So we're going to spend a couple days working on quadratic equations. We're going to focus on objectives 1 and 2 today. Tomorrow we'll look at objective 4. I'm not going to cover objective 3. Okay. Quadratic equations, if you recall, are equations where the highest degree is 2. And it will always have an x squared or a z squared or a y squared or something like that in order to be a quadratic. So we're going to first look at the zero product property. And what the zero product property basically is saying is either it's in factored form or we need to get it in factored form, and in terms of how to solve those. Now, in reality, we did some of that in 1.3. And now we're going to reinforce that idea. So essentially what this means, we're going to have one equation where we have to make one side 0, factor it, solve it. And that's what the zero product property states. Essentially what it's saying is if I multiply things together and the answer gives me 0, the product is 0, that means one or all of those things that are being multiplied together have to also equal 0. And so what we do when we solve these is we just assume that they all equal 0 and solve for each part. So this is on page 114, but it's pretty simple. You should be able to write that down. Y squared plus 3y equals 0. Now fortunately in this case, they made one side equal to 0 already. So all I have to do is factor. So how would I factor y squared plus 3y? Okay, so I'm going to factor out the greatest common factor, which is y. So I get y times y plus 3. Now again, here's where we're at. I've got one thing multiplied by another thing, and when I multiply two things together that equals 0, one or both of them must be equal to 0. So what we do is we just set each part of that, each factor equal to 0, and solve. So in this case, I've got y equals 0, and then I've got y plus 3 equals 0. Okay, and for many of you, you'll be able to just jump to the answer for here, which is fine. Okay, so this, either I get y equals 0, what's y going to equal over here? Negative 3. Okay, those are my options. That's the zero product property. This is something you've worked with many times in the past. Okay, but it essentially is the basis for all solving of quadratics. Right? If I have two things multiplied or three things multiplied or four things multiplied together that equals 0, each of those things we set equal to 0. Okay, that should not be new. Any questions about that? Okay. Sometimes, however, we'll have equations where one side is not already 0. There's two approaches to this problem, but I'm going to choose one of those approaches because it will always work. For those of you who are thinking of something else to do here, it would work in this problem, but it wouldn't work for all problems. So what I'm going to do first is I'm going to distribute this 10, and then I'm going to bring the 40 over. Okay? So that's what I'm going to do first. So I'm going to distribute that 10. So when I get 10 times 3x squared, what does that give me? 30x squared, and then the 10 times the negative 13? Negative 130. So this is the distribution. Now I'm going to bring 40 over. So now I've made one side 0. So what do I have to do now? Factor. So go ahead and do that. Factor that. Now, before I get into factoring this, one of the alternate method that I was sort of alluding to at the beginning was I could actually divide both sides by 10. Okay, and then that would have just left 3x squared minus 13x equals negative 4. The reason I chose not to do that is because it's not always going to be divisible. But I can always distribute. If this would have been a 9, it wouldn't have worked, right? I couldn't have divided. So that's why I chose to distribute. In this case, what is the greatest common factor? 10. So I take that back out. And I'm left with this 3x squared minus 13x plus 4. If you were trying to find factors of 1200 that add up to negative 130, like you're making your life really difficult by not immediately checking for greatest common factor. Now, here's the thing that's interesting about the 10. Okay, it isn't going to play a role anymore, since it doesn't have an x. I'm not going to say 10 equals 0 as as part of my factor over here, because 10 doesn't equal 0. In reality, what I'm doing is just focusing on this now. Okay, and so I'm looking for factors of 12 that add up to negative 13, which are negative 12 and negative 1. Okay, so when I factor, however you choose to factor it, that's what you should have gotten. 3x minus 1, 10 times 3x minus 1 times x minus 4. Okay, and if you're not sure how to come up with this, using box method, using grouping, using guess and check, that's something, again, spend a little more time on. Okay, now when I set these, I'm going to set each of these equal to 0. What's this one going to give me? X is going to equal what here? 4. How about this one? 1/3. Okay. So I've got to. So if you wanted to, you could set them both equal to 0 and actually do the work to do that. But you can also hopefully just go with the opposite sign, and then when there's a number in front of the x, you got to divide. So x equals 1/3 and positive 4. I don't have any fractions to begin with, so there's nothing that I need to check in terms of restricted values. Okay. Questions on either of those two problems? That is the zero product property. Make one side 0, factor, solve. Okay? The other type of problem we're going to look at is the square root property. And when you have the square root property, it's going to look one of two ways. Either there's no x term, so it's just going to be an x squared and a constant, or you're going to have a binomial squared. Okay? So we're going to go through each one of those types so we can see what you're supposed to do. Essentially, it's called the square root property because at some point we're going to take the square root of both sides and be able to solve it that way. Okay? You can always still look at factoring and use that, but typically speaking, the square root property is a little quicker, and your directions are going to say things like solve using the square root property, so you got to follow the directions too. Okay? So here's a case where there is, so then you're going to take square root of both sides. So here are my 3 examples that we're going to go through. Okay? And in this case, we are not making one side 0. What we're actually going to try to do is get the squared term by itself. So here the a squared term's already by itself. I'm going to have to get this c squared term by itself. And then here's the case of the binomial squared. So that is the term that is squared, and it is by itself already. Okay? And when I get that by itself, all you've got to do is take the square root of both sides, and then we'll be in good shape. So in this case, I'm going to take the square root of both sides, but what do? When you take the square root of both sides, what else do you have to include?
The sign.
Bella? Positive or negative, plus or minus, okay? So what this is telling me is because a is squared, there are 2 values of a that will give me 49. Okay, and obviously this problem is pretty easy, right? So when I square root both sides, I have the square root of a squared equals the plus or minus the square root of 49. And so the square root of a squared is just a, square root of 49 is 7, and that's my answer. So keep in mind, whenever we're solving a quadratic, you should get 2 solutions. Okay. Sometimes you might only get 1 solution and we call it a double root because technically it would occur twice. But in this case, when I take the square root of both sides, the biggest mistake that people make is they forget the plus or minus. You can write it as 7 and negative 7 if you would rather do that. Most of the time, we just leave it as plus or minus. Okay. On question B, I first need to get the c squared by itself. So what's my first move going to be?
Divide under 2.
You could.
Subtract the 80.
I'd subtract the 80 though, and then divide by 3. Okay. Again, with the square root property, we're trying to isolate the squared term. In either case, if you factor the 2 out first and divided both sides by it, you'd eventually get here. Okay. Now, when I take the square root of both sides, since I got the c squared, the squared term by itself, what's going to happen? What am I going to have here?
9.
Yeah, I'm going to have imaginary numbers because I can't have a square root of a negative. You can't take a number, square it, and end up getting a negative, so I'm going to have to use imaginary numbers. Okay. So when I do that, how am I going to break this down?
2 root 10.
Okay, before I get to that.
Times 4.
So I'd have negative 4 times 10, right? So what is the square root of negative 4? 2i, and then the 10 stays under, and we're good to go. Okay? So plus or minus 2i root 10 is my final simplified answer for that one. Questions? Alright, on the last one, please, 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 for square root property, do not FOIL this out. That is not what you're supposed to do. Okay? When you have a binomial squared, if I just undid that squaring by taking the square root of it, I'd just be left with the t plus 4, excuse me. Okay, so that's what we want to do here. We want a square root of both sides right away to get this squared to go away. So really what I have here is t plus 4 equals plus or minus. Now I already started breaking 24 down. The biggest perfect square that goes into 24 is 4. Square root of 4 is 2. So this is plus or minus 2 root 6. So I'm going to take that. What's my last step? Subtract 4. So my final answer, t equals negative 4 plus or minus 2 root 6. Okay, so today we're just focusing on zero product property. So make one side 0, factor solve, square root property, get the squared term by itself, square root both sides, simplify. Okay, that's it. Tomorrow we'll cover quadratic formula. I'm skipping objective 3, which is completing the square.
Thank God.
If you don't remember how to do completing the square or you want to review it, you're welcome to review objective 3. I'm not going to cover it.